we're able to use our knowledge of reference angles and our special right triangles to find trigonometric values between 0 and 360 degrees. We saw an example a few videos back where our theta was 30, 45, or 60 degrees, and now we're going to expand beyond acute theta values. So let's find the exact value of the 6 trig functions for each given angle, and we're going to start with 270 degrees. We're going to start by creating a diagram, determining the reference angle, using the appropriate special right triangle based on the reference angle, and then apply our trig definitions to get our exact values. Oh, 210 degrees. It's going to fall in quadrant 3. I'm going to drop a perpendicular down to the x-axis, and now we need to figure out what this angle right here is. Now, all the way to here is 210 degrees. We know that this much of it is 180 degrees. So to find that reference angle, we just need to do 210 minus 180, and that's going to give us a reference angle of 30 degrees. So that tells us we're going to use our special right triangle, 30, 60, 90, to find these trigonometric values. Now remember that the short side is across from the 30-degree angle, and we always label the short side x. The hypotenuse is 2x, and the long side is x times the square root of 3. Now there's one additional thing we need to think about here because we are outside quadrant 1. When we are in quadrant 4, we've gone to the left and down to get to this location here. So this is a negative value, and so is this. So what I want to say is our x value and our y value are both negative, but I don't want to be confusing because I literally have x labeled there. But our x value and our y value both negative in quadrant 3. Now that we have our triangle, we can just use our trig definitions to find the exact values. So sine of 210 degrees, that's opposite over hypotenuse. So opposite of the 30 degrees, that's going to be negative x over 2x. Let's cancel the x's out. That's going to simplify to be negative 1/2. Cosine of 210 degrees, that's our adjacent side divided by the hypotenuse. So that's negative x square root of 3 divided by 2x. X's cancel out. I'm left with negative square root of 3 over 2. And then tangent of 210 degrees, that's our opposite side over our adjacent side. So it's going to be negative x over negative x square root of 3. So notice that we're going to have a negative divided by a negative, so that's going to turn positive. And those x's cancel out. We're left with 1 over the square root of 3. which will then rationalize. And we're going to get square root of 3 over 3. Once we have these three, all we need to do is the reciprocal to get our other trig functions. Cosecant of 210, that'll be the reciprocal of negative 1/2, which is negative 2. Secant of 210, that's going to be negative 2 over the square root of 3, which will rationalize. It's going to be negative 2 square root of 3 over 3. And then lastly, cotangent of 210, be the reciprocal of tangent, but I'm, as always, going to grab the fraction I had before I rationalize it, and then flip that one. We're going to get positive square root of 3. And those are the exact values for our 6 trig functions when theta is 210 degrees. Let's do some more. Next up, our angle is negative 45 degrees. Starting in standard position, if our angle is negative, we're going in a clockwise rotation. Negative 45 degrees is going to fall in our fourth quadrant. Dropping a perpendicular to the x-axis, I create this right triangle, and we can already see what our reference angle is. Now, we're not going to call it negative 45 degrees. We're just going to call it 45 degrees. That 45 degree reference angle tells us that we're dealing with the 45-45-90 special right triangle. And I'm going to label the sides accordingly. Both sides are x, while the hypotenuse is x times the square root of 2. Now we just have to decide, though, whether the sides of the triangle should be positive or negative, depending on which quadrant we're in. In quadrant 4, the x side is positive, while the y side is going to be negative. And now we use our definitions. Sine of negative 45 degrees, that's opposite over hypotenuse. So here's our opposite side, negative x over x square root of 2. X's cancel, leaving us with negative 1 over the square root of 2, which we will rationalize. Square root of 2 over square root of 2. We get negative square root of 2 over 2. Cosine of negative 45 degrees, that's our adjacent side divided by the hypotenuse. Our adjacent side is positive x over x square root of 2. X's cancel, leaving us with 1 over the square root of 2, which we will rationalize and get positive square root of 2 over 2. Lastly, tangent of negative 45, that's our opposite side over our adjacent, negative x over x, simplifies down to negative 1. Once we have our big 3, we can get the others by simply doing the reciprocal. Cosecant of negative 45 degrees, that'll be the reciprocal of sine, and we're going to flip what we had before we rationalized it. So that'll be negative square root of 2 Secant of negative 45 degrees, the reciprocal of cosine. It's going to be a positive square root of 2. And then cotangent of negative 45 degrees, the reciprocal of tangent, which is negative 1. Those are the exact values for our 6 trigonometric functions when our theta is negative 45 degrees. It's all about finding the reference angle and then using our special right triangles. Let's do one more. This time our angle is 120 degrees. (120 degrees is going to be past 90. I'll drop a perpendicular to the x-axis, creating a right triangle. Now we need to find this reference angle here. We know this straight line is a total of 180 degrees, and our angle is 120 of it, so we just need to find the remaining part of it. We'll do 180 minus 120 to give us a reference angle of 60. So here we are again with our special right 30, 60, 90 triangles. I'm going to label the sides appropriately. Across from our small angle of 30 degrees is going to be our short side, which is x. Across from our big angle 60 is our long side, x square root of 3. And then our hypotenuse is 2x. We need to determine whether the sides of our triangles are positive or negative based on which quadrant we're in. In quadrant 2, the x side of our triangle is negative, while the y side of our triangle is positive. And now we're ready for our definitions. Sine of 120 degrees, that's opposite over hypotenuse. So opposite our 60, that's x square root of 3 over our hypotenuse of 2x. And our x's cancel out, leaving us with square root of 3 over 2. Cosine of 120 degrees, that's our adjacent side over our hypotenuse. Our adjacent side is negative x over our hypotenuse of 2x. X's cancel. This simplifies to be negative 1/2. Tangent of 120, opposite side over adjacent side. It's x square root of 3 over negative x. Simplifies down to negative square root of 3. We'll find our other 3 trig functions by doing the reciprocal of these 3. Cosecant is the reciprocal of sine, so cosecant of 120 degrees, that's going to be 2 over square root of 3, which rationalizes to be 2 square root of 3 over 3. Secant is the reciprocal of cosine, so secant of 120 degrees, that'll be negative 2. And cotangent of 120 degrees, it's going to be negative 1 over square root of 3. which will then rationalize. Simplifies to be negative square root of 3 over 3. And those are the exact values for our 6 trig functions when theta is 120 degrees.